Hey everyone, I'm here, and today we're going to talk about teaching polynomial functions. Alright, so let's talk about how to teach this concept. So what is a polynomial function? Okay, so generally speaking, when we are dealing with polynomial functions, we're talking about a function that has one or more terms that involve powers of variables. So for example, this right here, x to the 6th power plus 2x to the 4th power minus 3x to the 3rd power plus 9 is a polynomial function. And the reason why it is a polynomial function is because all of these terms have variable powers. Alright, so this is the general form of a polynomial function. Now, one thing that we need to remember here is that these coefficients can be real numbers. They can be rational numbers, irrational numbers, etc. Now the degree of this polynomial function, notice that the highest power of the variable here is 6. So this is a 6-degree polynomial function. If the highest power was 4, it would be a 4-degree polynomial. It could be any whole number, okay? But it has to be a whole number. It can't be like 3.2 or pi or 0.3093. It has to be a whole number. And when we are looking at the graph of a polynomial function, if the degree is even, so in this case the degree is 6, which is even, then the end behavior is going to be that as x approaches negative infinity, the function f of x approaches positive infinity, and as x approaches positive infinity, the function f of x also approaches positive infinity. Alright, so let's take a look at the next example. We got f of x equals x cubed minus 5x squared plus 3x minus 1. So first of all, this is a 3rd-degree polynomial, okay? Because the highest power of the variable x is 3. And if the degree is odd, so it's 3, 1, 5, 7, 9, etc. As x approaches negative infinity, the function f of x approaches negative infinity. And as x approaches positive infinity, the function f of x approaches positive infinity. Okay, next example, f of x equals 2x squared plus 5x minus 3. This is a quadratic, okay? This is a 2nd-degree polynomial, and since the degree is even, as x approaches negative infinity, the function f of x approaches positive infinity, and as x approaches positive infinity, the function f of x also approaches positive infinity. Okay, so let's take a look at the graph of a polynomial function. Now notice that this is not a polynomial function. Why? Because this right here, this is a rational function, okay? This is a fraction and we have a variable in the denominator. So this is not a polynomial function. This is a rational function. But if we clear the fraction, okay, if we multiply both of these by x, then we get x squared plus 3x minus 2. Now this right here is a polynomial function, okay? This is a 2nd-degree polynomial. And again, the end behavior is going to be, as x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x also approaches positive infinity. Now this right here, this is a 4th-degree polynomial, so it's even. And as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, the function f of x also approaches positive infinity. Alright, so now let's go ahead and find the y-intercept. The y-intercept is just the point where x is equal to 0, okay? So in this case, when x is equal to 0, this is the y-intercept right here. This is the point 0, negative 3. In this case, the y-intercept is 0, 2. And over here we have x is equal to 0. F of x is equal to negative 2. Alright, so the y-intercept is negative 2. Now we want to find the zeros of the polynomial function. Now what do we mean by zeros? Well, we are looking for the x values where the function f of x is equal to 0. So if we take a look at our first example, we are looking for the x values where x to the 6th power plus 2x to the 4th power minus 3x to the 3rd power plus 9 is equal to 0. Well, this is a little bit difficult to factor. In fact, there is no real number solution for this. So we're going to have to use the numerical methods to approximate the zeros. And what we get is that we have 1 0 here, another 0 here, 2 zeros here, and then we have 2 more zeros here. Alright. So that's finding the zeros of a polynomial function. And then of course we want to talk about the intermediate value theorem, which basically tells us that if we have a polynomial function and we have 2 zeros, well, there has to be at least 1 more 0 between those 2 zeros. Alright, So that is a quick review on polynomial functions. If you want to learn more, you want to see additional examples, you want to take some notes, you want to have some practice problems, check out the link below. You can download the entire lecture notes packet for this section and it will help you out a lot. Alright? Thanks for watching.